Hello folks, in a previous video I had shown how you could write your own custom road tile where a sprite would change depending on the road connections that are coming from the neighboring tiles. Now after watching that video, I'm sorry if I'm pronouncing this wrong, Einstein had brought up the question about how it could be implemented to create a custom tile for conveyor belts. At first, I thought converting a road tile into a conveyor tile should be a piece of cake. But oh boy, I was wrong. Technically, the difference between a road tile and a conveyor tile is actually very simple to define. Roads are both ways and a conveyor belt is one way. In other words, while a road tile picks a sprite depending on the existence of a road in the neighboring cell, a conveyor tile should pick a sprite depending on whether the neighboring conveyor is incoming or outgoing. Now we can start with creating our custom tile, and then we need to add an incoming and outgoing connections to it. So let's start with it. So we have a number of sprites that we can use, and I'm going to create, we already created a grid which contains a tile map. That's pretty straightforward. Now what I'm going to do, I'm going to create a custom tile script. Create script and call it conveyor tile. There you go. So it's going to be using Unity Engine tile maps naturally, and it's going to inherit a tile. Well, so we want to include some sort of information regarding the connections of the tile, and each connection has a direction. So we can create a public enum direction and it could be up, down, left, and right, simply because here our tile is our tile map is a square. So I'm going to create a dictionary that's going to convert these directions into vectors. So dictionary that will take from direction into vector. Call it direction to vector, and I can declare it right away. Paste here, new vector, and then declare it here. And we will probably also need to get the opposite directions as well. So we need to create another dictionary. Direction. Direction to direction, actually. It could be direction. Direction to opposite. Let's call it, and I'm going to define where I declare as well. Okay, so we have these enums defined. Okay, we need to be able to see it on the inspector. We have to make sure that this is serializable. Serializable. I don't see serializable here. I know it's under system, but serializable. Okay, that should be. So we can see this under inspector. Then we need some sort of rules to associate each sprite with incoming and outgoing connections. So I'm going to define a new struct. Let's call it public struct rule. And it's going to contain the sprite. It's going to contain, each rule is going to contain a list of directions for incoming directions and outgoing directions. Of course, this has to be also serializable. And then each tile, each conveyor tile can have a set of rules. So public list rule rules. All right, let's save and create a new tile. So I'm going to start tile map. I'm going to create a new tile map, call it new palette. I'm going to create new palette. Oh, it's here. And I'm going to drag only one of our conveyors here. New palette. And let's go conveyor connection. And when I do that, I should get an input here, the conveyor connection asset, but it is at the moment only a standard tile. So I'm going to go to debug and choose a tile and change that with choose a conveyor tile. And then I'm going to switch back to normal mode. Now I can see the rules. And I can fill up the rules. So I have all these conveyor tiles. So it's going to be, for example, 1. I know it's incoming from down and going up. So I just need to do this for each of them. Now this is a bit tedious. So we have all these tiles associated with these. So we can paint this. Of course, everything is same because it's only using the current sprite. Now, the next thing is when we are going to use the get tile data function. Let's go back and can override get tile data, and this is the key that everything happens here. But we have to consider that when two neighboring conveyors need to decide their directionality, since both tiles need to decide their direction depending on each other's directions, then both directions are equally probable and thus cannot be decided by looking at the neighbor. So at that point we need to force it. So we need a guide to the belt into choosing a direction. And that could be done by using a source tile, which is going to be only outgoing connections. So to add that, let's include a new parameter here. Here maybe public bool, let's call it static tile. And save and go back. And now we should have the option static tile. We can create another one here. This is going to be not connection. Let's call it source. And this can use only one type of tile. Where is it? One type of sprite, which is this one. It looks like more like a source. Okay, why everything changed? I thought these are. So look here, source is this one. Okay. Okay, it's because I chose to lock here. Okay, correction, not source. This one. And this can have and the source is going to have this one. Okay, so I can use source and connect here. So technically what the source will do is going to tell the next tile which way it should connect to. The thing is, the source tile can also have rules, but these rules are not for determining the sprite, but instead it can be used to tell the neighboring tile that it is an outgoing tile. So to do that, I'm going to go back to new palette, choose source, and on the rules, I don't need any rules. I just need one rule, which is going to have my source, and it's not going to have any incoming. It will be only for outgoing, down, left, and right. And because it's static tile, we won't have to update anything. It can just stay as this. So I'm going to include that check. So what I'm going to do, if it is not static, then I'm going to do something. So if not static tile, then we are going to do something. We have to decide the possible directions. So I'm gonna say let's start with list direction incoming, new list of directions, and list again direction outgoing, and new directions. And then we're going to iterate for the neighbors for each direction B in. So we're going to iterate through all the possible directions. So we can do that using the enums get values. And okay, we don't have enum. We need to include that in from the directory. I think it was in the system. We have enum, no, the system. Let's try. And yeah, it is. Get values from type of direction. You can iterate through this. Okay, I must be forgetting something. Yes, one more. Okay, so we're gonna check here for the neighbor. So for the position of the cell plus the direction to vector for the direction. So this is the neighboring position, and we need to get the sprite from that for s tilemap get sprite of this depth position, and then we need to get the tile as well, or tilemaps. Yeah, if we won't end up needing it, we can just remove it, but we need to make sure that it is a conveyor tile for the same position. And then we need to check if the sprite of this tile is actually have a matching rule, and from that rule we can get the outgoing directions, and the outgoing directions is going to tell us if there is an incoming towards this cell, this cell. So we need some sort of function that is going to help us identify if there is a if there's a match. So we're going to public rule find rule can be the function. It can get the sprite, and it can iterate for each rule are in rules. If sprite is rule sprite, then turn R. And there's also possibility that this cannot be found, and in that case we cannot return. It's not possible to say return null, because rule is a struct, not a class. We define it as a struct. We could define it as a class, but I think if it's a struct, it will actually work faster. And since we're going to have lots of tiles, this is a better choice. So instead of returning null, we can make this return a nullable variable. So now it's not going to return rule, it's going to return a nullable variable which has rule in its value. So I'm going to check variable matching rule, or we can just say R equals to find rule using the sprite. And then if there is a rule, then we need to get the outgoing directions and see if the outgoing direction actually contains the opposite of this direction. So I'm gonna say if, first of all, if R has a value, that means we found something, and our value outcome directions contains not the direction, because it's going to be opposite. So we had the opposite vector there, so direction to opposite, and so if it contains the opposite, that means this is indeed connecting to this cell. So we can simply add incoming dot add. We also check if there is a tile found in a particular position. Is null, then there is no tile map. We can just continue to the next cell. And if there is a tile but there is no matching rule, that means that it or there is no connection, then it means simply that there is a tile that might be an incoming that our cell can transfer its content to. So it's best guess we can add that, else if s is not null. So there's a sprite, but there's a tile and there's a sprite. It's basically the same thing. And we can include outgoing, can include our direction. Now, after we complete and find all the matching ones, we can find the rule that's going to match. So let's say, let's change this war rule, and it has to find, let's go through and find each rule. And to do that, we need to can create a new function here that's going to check for that. So let's say public, it can be also a rule, find rule, but this time we're going to have a list of directions for incoming and a list of directions for outgoing. And we're going to again iterate. So we're going to do the same thing. We're going to check two things at a time. If r dot incoming directions. Now I'm going to check if the two lists have the same content, but because the lists have orders, they might have the same things but in a different order, so it will look like it's a different thing. So to be able to check that, I can convert them into a hash set. So I can say, for example, why not I do a list checker? Public rule has identical content and list P for A and list P for B. And what it can do, okay, it has to be B is a type. We can return new hash set P A. So it converts A into a set, and sets don't have directions. And equal set equal. Yeah, this is the one. Set equal to B. So I can use this one. So I can even convert this into, no, don't worry. So I'm gonna check has identical content. Okay, this is direction. I'm wondering, do I really have to use this? Can I get away without that? No, I can't. So direction for incoming and r dot incoming directions, if they are identical, same content, sorry, and has identical content, direction, in this case, outgoing and r dot outgoing directions. That means our rule match. In that case, we can turn r, otherwise we can turn null. Again, this has to be a nullable variable. So I'm going to rule is find rule, and this time I'm going to enter incoming and outgoing. So it should match, and if it exists, if rule has value, then finally we can change tile data.sprite is equal rule that's value that's sprite and tile. Okay, yes, that's all. And that should be okay. Let's quickly check for this to make sure that we are actually seeing, to make sure we are actually in the right place. Why don't we just have call for a debug log and call it found rule and then we put value.sprout, and let's run this. Okay, so I'm gonna take this one, go around. Okay, so it does find conveyor 0 and conveyor 8 once. So here it says conveyor 0, which is this direction, if I recall correctly. Let's quickly check. Conveyor 0 is, yeah, that one. So there's no point. Oh, there you go. It's turning this way. Oh, and you go. There you go. But not here. Not here. Okay. Okay, it's actually working as long as this sideway is not working for some reason. Let's have a look at the sideway. Conveyor 1 is left outgoing right, coming from left. Okay, it's not going because this one, the static one, is not triggering. It has to trigger the next one. Okay, so for this one, it has to look into the rules, but the rules, it's looking its own rules, right? It needs to look the rule of the actual tile, the incoming tile, because every tile has its own rule. So the R find rule is actually should be called from the tile t dot find rule, and then it will look at the neighboring tile. So there you go. It automatically fixed its directions. And here, okay, it doesn't work in this direction. Do we have an issue? It should be conveyor 3 from right to left. It should be working. I think the problem is that there is already a sprite here showing upwards. Well, of course, that might be the problem. So if I change it with something, change the default sprite, I should be able to get the effect I want. So I'm going to change this with this one. Actually, I can get the empty, but it's better if I put this one so we can see everything. There you go. There you go. There you go. Everything is updated. Once I go over them, I have to go over them. For some reason, these are not working as expected, but there are too many of them, so let's clean sides. Okay, so this is not working obviously because there is 1 incoming and 2 outgoing. This wouldn't work, but if we do this, it will come this way, and then there you go. So everything is fitting as long as the source is available there. But if the 2 incomings are brought together, then you have a problem. Where is it supposed to go? It's a different story. All right, so considering a conveyor belt, it is quite common to bring different sources into same belt, but when it comes to separating, it requires more control mechanically and maybe also electronically. So we can actually consider creating a new tile, or a couple of tiles that are actually going to control the direction. We can also add one more feature so that the tiles that are in the neighboring sites are updated automatically. So what I'm going to do, I'm going to first get rid of this debug. We don't need this anymore. And once we have a rule found, we can iterate through the neighbors, except the incoming tile, So for each direction B in it values type of direction if the rule value, we should be looking for incoming directions, contains the, as long as it's not coming from that particular tile, and we are going to tile map to refresh the tile. However, I'm not really sure if we should do that right away. Maybe give a second, because if we do that, we might actually crash. Actually, let's save and see if we're going to somehow lose, and try that. Refresh tile, and what we're going to refresh is position plus direction to vector B. Oh, so it's going to refresh that tile. Okay, let's give it a try and see if we're gonna break anything. Okay, nothing yet. Oh, stack overflow. Okay, that's not what we want. We can give it a delay, and I don't know how the delay is going to be taken, but we can give it a try. So what we're going to do, we're gonna create a function that is going to call upon a delay, and we can use the either coroutine or an async function using system threading tasks. It has the async function, so I'm going to create a public, well, it doesn't have to public, private async void delay refresh. So it's going to be using a tilemap. It's going to use a position, int position, and it's going to have a delay. So int millisecond delay. It's gonna await task delay. It's going to be millisecond delay, and after waiting, it's going to tell tilemap to refresh that particular position. And so instead of this, we can say delayed refresh tilemap at same position and delay for 1 millisecond. I think 1 should be enough. Okay, this we have to change this to tilemap. Save it and let's give it a try. Okay, so I'm going to create some path. There you go. Okay, create loop. Of course, it's going to be problematic here because now it doesn't know which way it is supposed to go. But it is working. It didn't refresh anything until I go over 1 or 2 of it doesn't do because it comes this way. It doesn't know it's going this way or it's going that way. This makes sense. But if it thinks that it is going that way at first, then the next one is going to look like, oh no, it worked. Okay, I did the same thing. All right. There you go. Okay, so next thing we need to do is have a couple other tiles installed have a couple of other tiles here. It's going to determine the direction. So it's going to be like, they're going to be static tiles again, but they're going to have an incoming and outgoing directions. And during gameplay, different switch tiles, we can call it switch tiles, different switch tiles can be placed along the junction points. I'm going to start with a single tile, and I'm going to make copies of it. It's going to be static with rules. So it's going to be like source one. So I'm going to create a source, but change its name. It's going to be, let's call it switch state 0. Now this time we're going to use a slightly different set of sprites. Let's have a look at these sprites. Now, originally I have these conveyor tiles where most of them were one way, like one incoming, one outgoing, and a couple of them, some of them had 2 incoming, but always a single outgoing. Now, I'm going to include these ones. These are actually, they're all single incoming and outgoing tiles. The only difference is they have these valves on top of them to indicate which direction is allowed. So it is a sign that these are switch tiles. So let's go back to palette, select our switch state, lock it here. I'm going back to assets. I'm going to start from the first one. I'm just going to need, oh, I deleted all of them first. Okay, so it's going to come from down, it's going to go up. Yeah. Next one. Okay, so I have these. The only difference is this is a static tile, so it's not going to change its sprite. Let's choose a sprite here. Okay, of course, I have to put this in here. Here. Now, when I place this here, it will mean that it can only go upwards, and everything except these ones, you don't know where they're supposed to go, is set properly. If I was to remove this back, then these tiles go nuts. They don't know if they're supposed to be going forward or backwards. But if I put the switch, I have to put the switch here. Okay. Yeah. Put the switch here, everything's fine. Of course, not everything here is missing. So I need to make multiple tiles. So I'm going to create more switch tiles. But because I made the first one, I can just copy that one. Okay, so this could be taking 0, and this is going to take the next one. Let's not lock this. Don't make the same mistake. So it's going to. So we need to put these. We already had 0. If we have to put the rest of them in here. Okay, so I have all these switches here. So I can place these depending on my choice, and it will set the directionality. Like in this case, I'm gonna go over a different example when I'm talking about. Let's place 2 source tiles. Okay, so when I come here and here, now, and if I have 2 exits here, now in principle they're gonna come from here until here, both of them. Let's see them come here, but then they don't know which way they're supposed to go. By placing a switch, like for example, I want this to go down, left, this one. If I play this, and it will go down. And for this one, it can go here that way, or it can go downwards. So currently we have means to create a conveyor belt system using a conveyor tile and static tiles. So for example, the player can control static tiles using a switch, changing the tile sprite and automatically changing the flow. However, so far this is only working in the editor mode. For the player mode, depending on the needs, you would need to play around to make it fit your situation. Nonetheless, I hope this sheds some light on how a seemingly simple logical addition to a system can complicate the design. I think intrinsically using only one-way roads complex the traffic design, and maybe that's why we don't tend to see them more often. After all, conveyor belts are meant to be designed with minimum flexibility to where the cargo can go. I hope this was interesting and helped you out to some degree on how a conveyor system may be implemented. I will continue working on this in the future and maybe be able to make another video. Till then, good luck, and please let me know if you have any ideas or if you have found better ways to create such a system. Until then, good luck with your projects.